Hello, MGA. My name is Masaya Murata from Japan Aerospace Exploration Agency. Today, I will present our Lunar Navigation Satellite System, LNSS, and its demonstration mission. So this is joint work with my colleague from JAXA, Japan Aerospace Exploration Agency, and with aerospace companies in Japan and PhD students in the United States. Okay, I'd like to start by showing the outline of my talk today. I will first talk about our Lunar Navigation Satellite System, LNSS. Then its mission and system overview are presented. Next, the demonstration mission, our demonstration mission, currently scheduled in 2028, is presented, and its potential collaboration with the European Space Agency, ESA, and NASA is mentioned. Then I will finally conclude this talk. So our Lunar Navigation Satellite System, called LNSS, is in short a GPS-like system for the Moon designed by JAXA. So we are particularly focused on the lunar South Pole region, where the US Artemis Space Camp will be expected. So the LNS is to provide the positioning and navigation and timing PNT service at the South Pole region. And this figure depicts the overview. So I will talk about the detail later, but our LNSS is composed of two stable moon orbits, and for each orbit, 4 satellites will be deployed. So the total number of satellites becomes 8. So the LNSS also works as a communication relay satellite between the moon surface and the Earth. Indeed, among the 8 satellites, 4 satellites will also carry the communication payloads. So the LNSS will actually provide the communication, positioning, navigation, and timing CPNT service at the South Pole region. And this figure depicts the communication aspect of our LNSS. So we will use the Ka band shown in the blue arrows to achieve the transmission rate of 10 megabps and more. And if 1 gigabps rate is necessary, we will deploy the optical communication links shown in the yellow arrows. So there are 2 missions for our LNSS, that is positioning and communication. So originally, our LNSS has been designed to help our pressurized rover locate their own positions in real time at the South Pole region. So our rover will explore the South Pole region, and we need the real-time positioning service there. But our lunar user is not limited to the rover anymore, and astronauts' activity called EBA is also now within our scope. So this slide shows the satellite constellation of our LNSS, and we will use the 2 stable moon orbits called the elliptical lunar frozen orbits, ELFOs. So these orbits place our LNS satellites for long duration up above the South Pole region. Therefore, these orbits are suitable for accomplishing our purpose. Moreover, the stability of these orbits contribute to the less amount of satellite operation and fuel. So the rover exploring at the South Pole region will receive the navigation signals broadcasted from these LNS satellites, and the rover will perform the real-time positioning calculation in the same way as the GPS positioning technique. To be more precisely, the localization of the rover on the moon surface satellite image will be performed. So these moon surface satellite images taken by, for example, NASA's Lunar Reconnaissance Orbiter (LRO) will be transmitted to the rover prior to the exploration activity, and based on our LNS positioning result, the rover location will be identified by pixel level on the moon surface satellite images. So our positioning accuracy requirement actually came from the pixel resolution of these moon surface satellite images. So there are 2 major requirements for our LNSS. The first one is regarding the positioning accuracy, which is real-time horizontal positioning accuracy less than 40 meters at the South Pole region at any time. So the pixel resolution of the moon surface satellite images is now 80 meters. So its Hawk value, that is 40 meters, became our accuracy specification. As for the continuity, although the nominal operation duration for our pressurized rover is 8 hours per day, to support the astronauts' activity, we will need the one-day continuous PNT service at the South Pole region. Therefore, our positioning service will become anytime at the South Pole region. The second requirement is about communication, and to transmit the mission data taken at the South Pole region to the Earth, we will need 10 megabps and more. And the LNSS satellites will also carry the communication payloads and function as communication relay satellites using X-band and K-band. And to meet the 1 gigabits requirement, we will deploy the optical communication links. The technique is also under investigation. So this slide shows again our satellite constellation using 2 different aerofoils. And as I already mentioned, these orbits are stable so that we can decrease the amount of satellite operation on the field. And according to our simulation, we just need the satellite orbit correction once in a few months. And the orbital periods of these aerofoils are about 12 hours, and our LNS satellites will mostly stay up above the South Pole region. And the distance between the South Pole region and the LNS satellites will become 9,000 kilometers at the maximum. So there are 8 satellites in total in our constellation, and this constellation design enables the high horizontal positioning accuracy at the South Pole region and meets our accuracy requirement. To actually perform the PNT service, we will need to broadcast the LNS satellite orbit and clock information to the South Pole users. And the orbit determination for the satellite orbiting on the moon is not an easy work. And we also want to decrease we also want to decrease the operation and the processing cost at the same time. So we have been investigating several approaches, but we are now seeing the GNSS navigation technique using the weak signals as shown in this slide. So the GNSS is a navigation satellite constellation for the Earth and is composed of GPS and the Europe Sky Rail and so on. And the LNS satellites orbiting around the moon will receive the navigation signals coming from the first side of the Earth, because the GNSS satellites all pointed towards the Earth center. Therefore, the LNS satellite can only receive the navigation signals that pass the umbrella of the Earth. So we will perform the GNSS navigation using these weak signals on board the LNS satellites, and the orbit and the clock information will be transmitted to the South Pole users. So as for the communication, our requirement was 10 megabps and more, and potentially 1 gigabps. And these transmission rates are necessary for the mission data transmission from the moon surface to the Earth. And by using the LNS satellites and communication relay satellites, we have assessed the transmission rate and confirmed that 10 megabps and more could be actually achievable using the K-band. And we are also investigating the feasibility of the communication links to meet optical communication links to meet the 1 gigabps requirement. So our LNSS will also become the high-speed internet link in the cislunar space between the moon surface and the Earth. Okay, let's move on to our demonstration mission, currently scheduled in 2028. The objective of this demonstration mission is the evaluation of the lunar PNT accuracy in the actual moon environment. So we will place one LNS satellite in the EL4, and the satellite will receive the GNSS navigation signals as shown here, and broadcast the navigation signal towards the South Pole region. And we will also place one receiver at the South Pole region to perform the lunar PNT accuracy evaluation. So our demonstration mission is composed of one LNS satellite and one receiver that will be deployed in the Year 4 and at the South Pole region, respectively. And this satellite and receiver will be launched and delivered to the moon environment by our rocket and lander. And to obtain the ground truth data to compare, we will also use the Earth stations shown in the red to perform the long-term radio observation for the LNS satellite and the receiver at the South Pole region. To enhance the outcome of this demonstration mission, we are now discussing about the potential collaboration with NASA's Lunar Communication Relay and Navigation System, LCRNS, and the ESA's Moonrise systems. So these NASA's LCRNS and ESA's Moonrise system, lunar PNT systems are quite similar to our LNS, both providing the CPNT service on the South Pole region. So according to their timeline, at the year of 2028, some of their navigation satellites will be already placed in the moon orbits, and we would like to receive and process their navigation signals as well for the in-depth analysis of the lunar PNT accuracy. The important thing is that these different systems all comply with the same interoperability specification. So the receiver to be located at the South Pole region could process and receive and process these navigation signals to perform the positioning calculation. So, so this is our proposal right now to collaborate with NASA and ESA to do this lunar PNT experiment in the actual moon environment. So the interoperability among different systems has been one of the key issues in the GNSS community, which has been quite successful by the international efforts. And the same interoperability issue also applies to the lunar PNT systems under planning, such as the NASA LCRNS, ESA the Moonrise, and our LNSS. But thanks to the US LunaRnet interoperability specification, the navigation signals of these different systems all become the same. And related to the issue, the interoperability recommendation titled Coordination of GNSS and the Lunar PNT Systems for Lunar Operation was recently accepted by the International Committee on GNSS. So from now on, more and more active discussion about the lunar PNT interoperability will be expected. Okay, to conclude, I have presented the mission design, satellite constellation, orbit, and clock estimation strategy of our LNSS. And LNS will provide real-time and reliable CPNS service at the South Pole region for the benefit of all humankind. Our demonstration mission is currently scheduled in 2028, and to the best of my knowledge, this mission will become the first ever lunar PNT experiment on the South Pole region. And as already mentioned, this mission is not only about first ever lunar PNT experiment, but also will become the first ever interoperability demonstration mission in the actual moon environment. So we intend to perform to accomplish this mission together with European Space Agency, ESA, and NASA. Okay, thank you very much for watching this video. And yes, this is the end of my talk. Thank you very much.